So we continue with finding solutions to equations that contain radical expressions. The key thing to notice here, or to take note of, is that oftentimes we want to isolate the radical to one side and use squaring on both sides to solve for x. So here we have the radical on the left hand side and a number by itself on the right hand side. So I could simply square on both sides. The root and the square will go away, and x plus 1 would equal 25, and x is equal to 25 minus 1. We have x is equal to 24. You should always try to check your answer in a problem like this. So plug in 24 in the original function or equation. We have square root of 25, which is 5. So square root of x plus 1 is equal to 5 when x is equal to 24. So our solution is correct. This is something that we have to do when it comes to radicals. So the next one, we have a radical and a number. First thing to do is to move the number to the other side. If we do not do this, we're going to make the problem overly complicated. So now I have radical on one side, a number on the other. We square on both sides. So we have square root of x minus 1 squared equals 1 squared. The root and the square would go away. So we have x minus 1 equals 1, which would imply x is equal to 2. So since we have radicals, we should check our solution. So square root of x minus 1, I'm going to plug in 2 for x. So 2 minus 1, so I get 1. So 2 is a correct solution. Things are getting a bit complicated here. This is a lengthy problem, but the same rules apply. We keep the radical on one side and move the rest of the terms to the other. So we square on both sides. So square root of x plus 1 squared would equal 8 minus 2x squared. The root and the square would go away. So x plus 1 would equal 8 minus 2x times 8 minus 2x. So x plus 1 would equal 64 minus 16x minus 16x plus 4x squared. So x plus 1 would equal to 64 minus 32x plus 4x squared. We move all the terms to one side, so we have 4x squared minus 32x minus x plus 64 minus 1 equals 0. That gives us the equation 4x squared minus 33x plus 63 equal to 0. So we have to see if we can factor this. We can factor this expression, and the factors are, how do we get, so we could have negative 21x and negative 12x. So negative 21x, negative 12x is negative 33x, and then we'd have 63. The common factor between the first two terms is 3x. So if we pull out 3x, we have 4x minus 7. And if we pull out 3, which is in common between the two, see here, I could perhaps write this in a different way. So that it'll be easier. So there is a 4x in common between the first two terms. If I pull that out, I have x minus 3. And I have a negative 21 in common between this last two terms. If I pull that out, I would have x minus 3. So 4x minus 21 times x minus 3 would be the two factors. This would imply x is equal to 20. We'll set each factor equal to 0 and solve for x. So 4x minus 21 equal to 0 would imply 4x is 21. X is equal to 21 over 4. And if we set x minus 3 equal to 0, x is equal to positive 3. Don't forget to check. I'm going to check here on this side. So I'm going to plug in 21 over 4 in the equation. So 2 times 21 over 4 plus square root of 21 over 4 plus 1, which is 21 over 2, plus square root of 21 over 4 plus 4 over 4. That would equal 21 over 2 plus square root of 25 over 2, which would give us 21 over 2 plus 5 over 2. Now, you look at it and you say, oh, I get 26 over 2, and that is not a solution. In other words, that doesn't fit the equation. So think about it. It is plus or minus 5 over 2. So if we plug in negative 5 over 2, we would have eight, but that isn't the case here, so it is not working, because when I plug in 21 over 4, I end up getting 13, so that is not a solution. Let's see if 3 works. So I'm going to plug in 2 times 3 plus square root of 3 plus 1 in the original equation. I'm plugging in 3 here, so that would give me 6 plus square root of 4, but square root of 4 is 2, so I would have 6 plus 2, I get 8. So x is equal to 3 is a solution. So here we have another lengthy problem, and this is going to take some time, so pay close attention, because a lot of algebra is involved. So the first step, since we have 2 radicals, we are going to start with squaring on both sides. So the left-hand side is quite easy. the root and the square would get cancelled. So we have y plus 5. The right hand side, I can write it as 2 minus square root of y minus 4 times 2 minus square root of y minus 4. Which would give us y plus 5 equals 4 minus 2 times square root of y minus 4 minus 2 times square root of y minus 4 plus square root of y minus 4 squared. I'm simply foiling here. So y plus 5 would equal to 4 minus 4 square root of y minus 4 plus y minus 4. Why is that? The root and the square would get cancelled. So I am going to move terms after simplifying. So I see a 4 and a negative 4 there. So that would go away and leaving us with negative 4 square root of y minus 4. But we also have a y here, so I'm going to move that y to the other side. So I have y plus 5 minus y equals negative 4 square root of y minus 4. So those two terms would go away, and that would reduce to 5 equals negative 4 square root of y minus 4. So negative 5 over 4 would equal to square root of y minus 4. Now we have to stop and think about it even before we proceed with this problem. And we're going to assume positive solutions here. So if you look at that function, the smallest value that y can take is 4. So the domain is y greater than or equal to 4. And no matter what you put in there, we are not going to get a negative number. So since we're not going to get a negative number, this one has no solution. Again, keep in mind the assumption here is y, or the solution for y is a positive real number. So we are expecting a positive real number, so no matter what positive real number greater than 4 I plug in on the right hand side, I'm not going to get a negative number. It's just not going to happen, so there is no solution. Is there an alternative way to do this? I'm going to simply put a box here and do it. Or I could do it on the top here. So I can square on both sides. Which would give me 25 over 16 equals y minus 4. Move the 4 to the other side. Y equals 25 over 16 plus 4. Which if you combine, you would get 89 over 16. I'm going to let you try this. If you plug in, so note, So if you plug in 89 over 16, the right hand side will not match the left hand side. So again, there is no solution. I personally find using the domain and coming to a conclusion as a better option. And we are looking for positive real numbers, and keep that in mind. We want positive real numbers as the answer. So here is another example. We have two radicals, and we could take the same approach that we took in the previous problem. We take one of the radicals and move it to the other side and go from there. So we have square root of 2x minus 4 equals negative 2 plus square root of 3x plus 4. We square on both sides. So the root and the square would go away on that side. And on the right hand side, we have to FOIL. So 2x minus 4 would equal minus 4 minus 2 square root of 3x plus 4 minus 2 square root of 3x plus 4 plus square root of 3x plus 4 squared. So I have minus 4 times square root of 3x plus 4 the root and the square would go away, and I will have 3x plus 4. So the 4 and the negative 4 would go away, and we would simply have 2x minus 4 equals negative 4 square root of 3x plus 4 plus 3x. And let's move everything to one side. I jumped the gun here, so negative 2 times negative 2 is positive 4. So we would have 4 and plus 4 here. Move all the terms to one side. So we have an 8. So 2x minus 4 minus 8 minus 3x equals negative 4 square root of 3x plus 4. 2x minus 3x is minus x, and negative 4 negative 8 is negative 12 equals negative 4 square root of 3x plus 4. I have a negative in common on the left hand side, so I pull that negative out, and I am going to get rid of the negatives. So x plus 12 would equal to 4 times square root of 3x plus 4. If we square on both sides, again, because we still have a radical, so x plus 12 squared would equal to 4 square root of 3x plus 4 squared. FOIL on the left hand side, x squared plus 24x plus 144 would equal to 16. The first term squared. When I square the root and the power, they would get cancelled, and I would simply end up having 3x plus 4. So x squared plus 24x plus 144 would equal 48x plus 4, or 64, sorry. Move all the terms to one side. X squared plus 24x plus 144 minus 48x minus 64 would equal 0, which would give us x squared minus 24x plus 80 equals 0. So we have to come up with, this is a quadratic equation that we can factor. So we could factor this as x minus 4 times x minus 20 equals 0. So set the first factor equal to 0 and the second factor equal to 0. When we plug in which would mean x is equal to 4 is a solution and x is equal to 20 is the next solution. So we want to verify if x is equal to 4 is a solution. So I'm going to plug in x is equal to 4 in the original equation. So square root of 2 times 4 minus 4 minus square root of 3 times 4 plus 4, and I need to get negative 2. Let's see if we get negative 2. 8 minus 4 minus square root of 16. 8 minus 4 is 4, so square root of 4 minus square root of 16 is 4. So I get 2 minus 4, I get negative 2, so the first one is a solution. And you may ask, well, why do we have to check this? Keep in mind, anytime we have radical equations, we have to check if the solutions work out. I showed you an example earlier where it did not work out. So now I'm going to plug in the next solution, which is 20 in the equation. So square root of 2 times 20 minus 4 minus square root of 3 times 20 plus 4, which would equal to square root of 40 minus 4 minus square root of 60 plus 4, which would be square root of 36 minus square root of 64. Square root of 36 is 6, square root of 64 is 8, 6 minus 8 is minus 2, which is the right-hand side that we expect over there. So that checks out as well. So both x is equal to 4 and x is equal to 20 are solutions to the equation. So we are going to use the Pythagorean Theorem, and I mentioned Pythagorean Theorem I believe in the previous video. So the theorem is quite simple. We have a squared, a as length of a triangle, and b is another length, and the diagonal here is the hypotenuse. And Pythagoras came up with this formula that a squared plus b squared would equal c squared. And we want to solve for this example, or using this example, and the Pythagorean theorem. So we want to find the length of the hypotenuse of a right-angled triangle, where the length of the two legs, by two legs we mean that, and that, and we'd like to find the hypotenuse. So we'll call that A, we'll call that B, and we're trying to find C. We know that the formula is A squared plus B squared equals C squared. So 2 squared plus 7 squared would equal C squared. 4 plus 49 would equal C squared. We take the root on both sides, square root to be precise. (53) would equal to C squared, which would mean C is equal to square root of 53. And you may ask me, well, why can we not say plus or minus square root of 53? Well, minus square root of 53 cannot be an answer because the length cannot be a negative number. So the answer is simply square root of 53. So here is another example where we have a right-angled triangle, and C is given here. In other words, the hypotenuse is given. So if you look at the figure here, leg A is that side, leg B is that side, and hypotenuse is that sloping line. So A is given, which is 2 meters. C is given, which is 9 meters, but we do not know B. Again, we use the formula A squared plus B squared equals C squared. So 2 squared plus B squared equals 9 squared. 4 plus B squared would equal 81. B squared would equal 81 minus 4, and B would equal, or B squared would equal 79, which would imply B equals square root of, 77. Square root of 77. You could find the decimal value using a calculator.